Don't worry. Is he important? Started or not? Yeah, it is started. So I will do it again for you. So let's see how we're done. So first of all, you have to go on this particular KEIL Microvision 5 shortcut, which will be created on your desktop. So just click on that. It will open the software that is a KEIL 5. I'm showing you how to program 8051 in KEIL 5. That is in and that too in assembly language. Okay. So let's suppose I will just close all the projects. Fine. Yeah. So let's suppose this is the blank page which is open to you. Now you have to just create your new project. So for that, do not go in file because that is whatever no, that is what we do normally. But I will suggest go in a project, say new microvision project. Fine. Then give that project a name. That's a B4. Now it will be there. Just a B4 KJ add. Okay. Now this suppose this is what project ka name which I have given. Okay. Normally give meaningful name to the project. Okay. So here I'm just saying before KJ Somaya College and addition is a program. Fine. Then say save. After that, it will ask for we have to select the controller which we want to program. Okay. So if it is showing down arrow like this one, then select this legacy database, legacy device database. Otherwise, it will be available to you directly if you're not installed that rest of the controller like AVR and ARM and all. Getting it? Okay. After that, search for your IC over here. So we are going to program 8089C51, which is available directly from here. Also means you can just go to the company which making it, that is a microchip. Yeah. So if you just go to the microchip, if you just open this one, then there will be 8089C51. Yeah, this one. This particular one. Fine. This is the 8051 base IC. This is what we want. In the description, you can get it. Fine. Otherwise, you can just search directly in this search window. So I'm saying 8089C51. That will also do. So ultimately, you will get the same IC. Okay. Either you can navigate through the companies or you may just directly put it in search bar. Fine. Anything will do. So say okay. Fine. Then afterward, it will just ask for this particular startup file. Now, this is optional. If you want, you may just add. Otherwise, if you do not add, then also it won't harm your program. Because now this is the file which is very much required for a C programming. If you're just doing embedded C programming for the 8051, so in that case, yes, you have to add this particular startup file. Okay. But if you are doing in assembly, then if you say no, then also it will be fine. And it will allow you to program and execute as well. Okay. So I'll just say no. Okay, so after that, you can see over here, it has created a project that is a B4KJ add, and here you can see the target one. Fine. Yeah, you can just rename all this one, that is fine. But right now, I will not do that. Yeah, if you just click on this particular plus file, you will see the source group. And now here you have to add your assembly file. Getting it? So I will just say right click. Now, if you just right click, it will just give the this particular options. Now here, just go in, add new item to the group. Okay, so I'll just click on this one. Then it will ask in which language you want to program, C, C++, assembly, or you just want to make a header file or a text file likewise. Okay, so now as I told, we are going to do it in assembly language. So you can just select on this one, assembly file. It will take this extension as a .A51. So this is a extension for the assembly file. Okay, and if you want, you may just rename that particular file. Let's say I will say addition. Okay, so I will say add. It is saying it's already exist. Okay, I will just say P4 PJ add. Okay, so I'm just giving the name to the file, say add. Okay, so it has added this particular file that b4kj add.a51, and you can see in under the source group you will get this file. So now this particular file is added to this particular source group, and it is a part of this particular project. Okay, now here you can start programming. Now you can start programming. Okay, now how to start? It's just like this one. Let's see. I've actually opened some program, but okay, it is not there. Yeah. Okay. So normally the starting is just like this one. We have to say org. Normally just do it in caps lock. So org 0000 h. Okay. So this is just for origin, nothing else. So you have to say that org 000 h. Fine. Then you can start programming. So I will just say, let's suppose I will write program. Let's suppose I will do it for the addition. So I will just say move a comma hash 21h. So this is how we have to program. Let's suppose I'm taking A as the accumulator, which is there in a block diagram we have seen. So I'm just moving that 21 to the A. But how do we move? We have to give the asterisk sign before that 21. That is how that assembly language is, the syntax for the assembly language. Okay. So now I say move. Let's suppose I will take a register like R0. Now we have seen we are having another register like R0, R1, R2, R3, R4, R5, R6, R7. Not AH, BH or CL or DL like 886. We are in 8051 now. So the register which are available is a register. Okay. Then R0 to R7 register. So these are the register which with which we have to do the programming. Fine. So I will just say move R0, comma hash, let's suppose 34H. Then I will just say add A, comma R0. Okay. And that's it. And after that, you may just write halt. Not taking it as an instruction. Just a minute, let me just confirm. Yeah, we have to say end. Okay. So in assembly, you have to just say end, not halt, you have to say end. Getting it? Okay. So the program got success like this one. We have to just start with the org00. Means this is what from where we are going to begin the program. So from 000 location in ROM. Okay. Then move A, comma hash 21H, move R0, comma hash 34H. Likewise, you have to just keep on writing a program. And at the last, you have to just say end to just indicate that this is the end of the program. Fine. So this is what you have to do. Say save. Okay. Now after that saving the program, you have to compile it. Now to compile, here are the options. Here you can see the options. Okay. So here is a build and rebuild. These are the options. Build is what just for compiling, or you may say the building a program. Now in this KEIL, it is called the build, or you may say normally compile. One is the same thing. Okay. So we have to just build this one. So I will just say build, click on this. And here you will get the errors and warning if you are present in a program. Getting it? So here we can see now 0 error, 0 warning. So yes, your program is syntaxically correct. We can't say logically, but syntaxically it is correct. Getting it? So you must, after the building, you must get that 0 error, 0 warning. Okay. Now, after to run this particular program, what we have to do, let's see. So to run this one, you have to just go over here. You have to just go over here. Okay, on this particular take a debug symbol. Fine. And you have to say the start and stop debug session. So you have to just click on this one. Right on the side, run करने के लिए we do not have any direct play button which we used to have in C programming and all. ठीक है? So आपको करना क्या है? First of all, just go on this D button, click on this. Okay, this is directly running it. Yeah, you just directly click. Problem. Yeah. Audible now? Guys, कुछ मिस नहीं हुआ ना? हेलो, कुछ मिस हुआ क्या?
No, sir.
Okay, okay. बस बीच में connection okay, fine, no problem. Just continue. Yeah. So as I told you, have to just click on this one, start and stop debug. So it will just change the thing. ठीक है? अभी ये change क्या क्या है समझो. Just I will give you थोड़ा सा idea. ऐसा ऐसा you will be master in this one. Don't worry. Okay. So here you can see all the registers which are there in 8051, like R0 to R7, then A, then B, then a stack pointer, max, DPTR, PC, and whatnot. Okay. Then this is regarding the PSW. That is what our program status bar. So that's if you want to check that each and every bit, then you can just click on plus and you can see this particular one. Fine. So this is what the registers will be open to you. Okay. Then and here what we are having is that it's a D assembly. So जो भी assembly level का program था, ठीक है? It has converted into the hex code. Fine, because finally that 8051 going to execute that 0 and 1. Are you getting it? Or you may say that hex code program. Okay, not what that we have written in move and vagara. Getting? Because it doesn't understand that move a comma something. It just understand zeros and one. So that assembler will just convert this into the assembly language. So you can see over here. So first instruction which I have written that move a comma hash 21h. Okay, so 21h, wherever at that edge, it can be also represented like 0. You can see 21h if I just click on that one and not click, just hover the mouse on that. So it will just say 21h is equal to 0x0021. Okay, so how do we if you find 0x before any number now, if you in this yellow line you can see over here, so it's just like move a comma hash 0x to 1. So this is how it is converted. Okay, so if I just say like this one, so its meaning क्या होता है कि 0x means what, the number which is present next to it is in hexa. Getting it? It will not say 21h, it just says 0x. So 0x means what, the number which is present next is in hexa. Getting it? So move a comma 0x21, this is the instruction, and which is converted like 7421, which is converted like 7421. Understood? Okay, so this is 74 is a code for move a comma something, a comma immediate number, and 21 is the number which we want to move it to the a register. Okay, likewise we have written another instruction like move r0 comma hash, sorry, we have written actually move r0 comma hash 34. The brown one you can see, this is what which we have written, and here you can see it is a converted one. Let's show all. Getting it? Okay, so I'll just say move r0 comma hash 0x34, so that's converted like 7834. Getting? So 70 is the code for move r0 comma something, or move r0 comma immediate data, and 34 is the data which we want to. So this is how it is converted into the code. So it's just 7421 and 7834. This is the actual code which is going to be executed by 8051. I hope you all are getting it. Fine. Then I have written that add a comma 0, a comma r0, and for that the code is 28. That's it. Getting it? Okay, so this is how the program is getting encoded in machine level language. So this is what you can see over here. Okay, and to run this one, either you may just do the single stepping. This is called as single stepping. Otherwise, you can just run the entire program. Okay, so this is for just a single step 1, step 2. But likewise, you can do single stepping from this one. And if you want to just run entire program, then you can just click on this one. Fine. So let's suppose I will do the single stepping. So if I just say like this one, yeah. So first of all, it has executed this. Now you can see this particular green one. Ready? So this particular green bar, what it indicates, this particular instruction is executed. That move a comma hash 21. Now because of this one, that 21 you can see it is in A register here in a system register. You can see A, and in A we are getting that 21. Okay. Now if I just click on another step, yeah. So you can see, yeah, ये दो instruction execute. That's why they are turning into the green. Okay. So it has just executed move R0 comma hash 34. Now you can see that 34 is there in R0. Fine, 34 there is in R0. And whenever I just click on this one, so we just add a comma R0 and it will place the result into A. So that's why in A you will see the new number which is a 55, which is the addition of this to 21 plus 30. Getting it? So this is the addition which you can see it in accumulator. So this is how we can just execute a single step. Otherwise, if you just click on this one, run, so pura it will just execute that entire program. Getting it? Okay. So this is to you for doing that single stepping, and this is for just executing the program in one shot and to see the result over here. Ready? So this is how we can just see the result in this register. Fine. If you are just using memory and all in your program, then that is also possible to check. So you can just go on view. Now here you can see a lot of options are there. So you can just click on this memory 1. Okay, where is the memory? Let me just get it again. Yeah. So here you can see the memory 1, and here if you want, I will just say. Okay. Okay. So now it has just shown the code memory. You can see from here that code. It has just shown that internal ROM that is from 000. And as I told, this is what we have said that org 00. So that's what the program is going from 000. Okay. So what is the code you can see over here? 74, 24, 78, 34. You can see over here also. Okay. And 20 is 20 for the addition. Getting it? So this is what that code it has just converted into the machine level or hexa code, or you may say the operating codes, and it is stored into this memory from 00 onwards. Okay. If you want to see the data memory, then that is also possible. You can just say view. You can just take one more memory window. Let's suppose I'm saying memory 2. So it will just open side में. Okay. So data memory I think you have to give that D. This is the data memory. Okay. Now can anyone tell me why 34 is over here? This is what our internal RAM is, and if I click on memory 1, this is what internal ROM is. Getting it? This is ROM, and this is the RAM ka space. Okay. So can anyone tell me why 34 we are getting over here? Can anyone just think on this, or anyone can answer this one? Why we are getting 31 over here? This is a data. See, D means what is a data memory, and C means what is a code memory. Okay. So this one is a code, and here we are getting 34. Anyone can just link this one, or you can just can connect whatever we have learned with. Okay, let it be. If you just get the answer, you can just send me later on. Okay, so this is how you have to just use a KEIL, and yeah, this is how we can just check the content, or you may see the result in the registers over here. And if you want to check it in memory, you can just go over here. Means you can just say view, and you can just open up the memory window and fine. You can just check your memory location which you want to see. Okay. Likewise, if you want, actually, just a minute. Yeah, if you want to check your peripherals, means if you want to check it in your IO, means we are having all the ports. So now if you want to check the port ka control, so that is also possible. You have to just click on that port ka lines. Okay, so if you just see the port 0, if I just click on a port, let's suppose my output is there in a port 0. Okay, so if you just click on a port, so it will just open that all the pins for the port, means what are the flowing on that port, or what are the content of the particular port, the pins that can be seen over here. Okay, so when you see the tick mark means what is a 1, and if it is a blank, it is shown as a 0. So this is what the syntax which is followed in the KEIL. If you see the tick mark means what, the 1 is present on the pin, and if you see blank means 0 is going on that pin. Getting it? Okay, so likewise you can check for all the ports. Likewise, if you want, you may just check it for serial communication, or the timer and timer. You can say timer 0, timer 1 we are having. So what are the peripheral output, or whatever you want to check? Yes, is possible for you. Getting? Now afterward, if you want to see the graph of that particular pin, that is also possible by using this logic analyzer. But we will see this slowly. Okay, in the next practicals and on. Getting? So if you want to check that, if you want to check the signals on a pin, or if you want to see the graph of it, or if you want to see how the signal is varying, so that is also possible. You can just go in logic analyzer. You can just enter that pin ka name, and yes, you can get the waveform on that particular pin, of that particular pin. Fine. So rest of the tools I want you to explore. I will not show each and everything, because I have just shown you what are the required is, what are required for dealing with the skill, that is I have covered. And we do have a lot many options you can see from here, but I want you to explore all the things. Getting it? So that's all. That's how we have to just run the program. I hope you have understood the addition of the two number and how to see the result. So you can see here the result is at a comma r0. So that's why result is in accumulator, and we can see 55 here. Fine. So that is how we have to use KEIL for 8051. That's all from my side. I will stop the recording, and you can use it later on whenever you want to revise this again, how to use a KEIL. I'm stopping it.